such an honor to be here. My name is Berger. I'm a Master of Architecture student at Parsons The New School for Design in New York City. Along with other students and faculty from the New School and Stevens Institute of Technology, I've been working for the last year on a project called Empowerhouse. The project began as an entry into the U.S. Department of Energy 2011 Solar Decathlon, a biannual competition that challenges 20 collegiate teams to design, build, and operate small solar-powered houses. Over the course of 3 weeks, the houses are assembled in Washington, D.C., exhibited to the public, and judged by professionals in 10 categories, ranging from energy production to market appeal. But we weren't aiming to be the shiniest house in the competition. A lot of technology that's needed for tomorrow's housing is already available. The question we've been trying to answer is more social than technological. How do we actually bring these green solutions into neighborhoods? We wanted to have our work extend beyond the competition and affect real change in sustainable housing. So we partnered with DC government agencies and Habitat for Humanity, which is an organization that builds affordable, energy and resource-efficient homes for people in need, to design a competition entry that would transform into a permanent home in the region. Empowerhouse is a site net zero energy home, which means it produces as much electricity as it uses in a year. A small solar array produces the energy to heat and cool the home, power the lighting, and run the hot water heater and electric appliances, eliminating costly electricity bills and reducing the use of fossil fuels that contribute to global climate change. But solar panels can be expensive, so in order to build a solar-powered home that is also affordable, Empowerhouse is designed according to the Passive House standard, consuming 80% less energy than a conventional home. This allowed us to minimize the size and therefore cost of our mechanical system and solar array. To meet the Passive House standard and achieve these incredible energy savings, Empowerhouse has a highly insulated, airtight building envelope with high-performance windows and doors and glazing and shading placed to control solar heat gain. Additionally, the mechanical components work together to improve the overall efficiency of the home. In the winter, a device called an energy recovery ventilator reduces the amount of energy needed to mechanically heat and cool the home. It uses the heat of the exhaust air to preheat the incoming air, and in the summer, the system works conversely to pre-cool the air. So the form of Empowerhouse was designed for transportation and replicability. The mechanical room, bathroom, and kitchen anchor the house on the east in a wet module. Grouping these spaces allows a more compact mechanical system and necessitates fewer connections to be made when bringing the two modules together. The bedroom, light loft, and living room are aligned on the west side of the home in a dry module. These spaces feel open and airy with many windows providing natural light. Large high-gain windows on the south side allow the winter sun to warm the home. Here, the open kitchen, dining, and living areas benefit from large amount of glazing and feel extended into the backyard. And a thick envelope then wraps the home, and it's an easily constructible but unique system made of engineered wood eye joists that are sandwiched between wood sheathing, creating a 12-inch cavity that is then filled with blown-in cellulose. And this is a really thick wall compared to typical construction. The envelope is then extended to create generous and inviting porches. The front porch has historically been an integral part of American culture, and the tradition is still thriving today in DC. Serving as a transitional space between the private family world and the public realm of the street, it is a place where neighbors can interact and build a strong community. Local, renewable, and non-toxic materials were used throughout to ensure Empowerhouse is a safe home with healthy indoor air quality and a low impact on the environment. The project was very well received by the public at the competition and proved to be the least expensive of all 20 houses, winning us first place in the affordability contest and solidifying that this model is the most suited for replication in the affordable market. So after the competition, the house was moved to the DC neighborhood of Deanwood, where it is currently being expanded into a 2-story, 3-bedroom home and joined by an identical second home by Habitat for Humanity volunteers. The two will soon become homes for families in need selected by Habitat. Here's a rendering of what it will eventually look like in Deanwood. And the porches come together here to unite the homes, further fostering community interaction. And when joined, the two units will achieve peak energy efficiency by reducing the envelope that is exposed to the outdoors. So while constructing a solar-powered passive house costs about 10 to 12% more than Habitat's current models, this upfront cost is more than offset by the elimination of utility bills. For a comparably sized home in the Deanwood neighborhood, utility bills are about $2,300 annually. And with energy prices predicted to continue rising, over the course of a Habitat home's average 30-year mortgage, a homeowner could save up to $132,000 or 996,000 rand. Throughout the process, the team has worked closely with community leaders and Habitat to make policies and practices more sustainable. The ultimate goal moving forward is to enable a large-scale implementation of this model, providing affordable, energy-efficient housing to more communities worldwide. Thank you very much.